Okay, as usual, we've got two linear inequalities, and then altogether this compound inequality. And start off by solving each of the linear inequalities. So we want to get the x term by itself, so we start by adding 1 to both sides of this one. And to get the x term by itself, we take 7 away from both sides of the second one. This leaves 9x being bigger than 17 plus 1 is 18. And this one results in 2x being less than or equal to negative 21, negative 7 is negative 28. Now we're almost there. Just have to get rid of the coefficient here by dividing it away, dividing the 9 into both sides. And this, we divide both sides by 2 to cancel out x, the coefficient of x. So this results in x larger than 2, or x is less than or equal to negative 14. So we've solved each of our linear inequalities, and now it remains to see what the solution to the conjunction, well, not conjunction, but this compound linear inequality with an or. Or, remember, refers to the union, which means we're looking for any solutions that are either in this solution set, or in this solution set, or in the overlap of the two solution sets. So we're going to graph this solution set on one line, right here, x is greater than 2. The second solution set we'll graph on a second line, and then we'll put the solution we're looking for of the compound inequality on the third line. So we need a negative 14 and a 2 on our number line, so negative 14 is to the left of 2. So here's negative 14 on each number line. Here's 2, the number 2 on each of these three number lines. So graphing that x is bigger than 2, well, that means everything to the right of 2. That's where the numbers that are bigger than 2, greater than 2. So that's the first solution set graphed. X is less than or equal to negative 14 means everything to the left of negative 14, and including the negative 14 here. So the or, we throw all these solutions together into one solution set, so taking their union. So these are included. So we have everything going off to the left from negative 14, any x's that are smaller than negative 14, but also we have, these are solved by any x's that are bigger than 2, and since being a solution to one set or the other means it's a solution to the or of these two, that's the graph of our solution set. And as usual, you can imagine a negative infinity living at the end of the number line to the left, positive infinity living to the right of the number line. And then we can write this in interval notation by saying this part is the set of all x that are between negative infinity and negative 14, including the negative 14, along with, so that's union, the set open that goes from 2 out to infinity, not including the 2 here. So this is how you'd write the solution in interval notation. You have to use the union symbol to join these two separate regions together. In set builder notation, this is also written as the set of all x such that x is greater than 2 or x is less than or equal to 14, basically. You can say, or we could say x is less than or equal to negative 14, or x is bigger than 2. So, yeah, the word or shows up in the compound inequality as well as in the statement of the problem. So there we have the graph of the solution expressed in interval notation, and the solution expressed in set builder notation. And we've got it.